to be making our review video for Chapter 11, Section 6, Chapter 11.6. So we're going to be doing our learning target. Our learning target today tells us we're going to learn how to display and interpret data in a box and whisper plot, a blocks and whisker plot, if I can talk right. New vocabulary, we need to know about a box and whisker plot. So here's the definition. A diagram that summarizes data using the median, the upper and lower quartiles, the extreme values. The box is drawn around the quartile values, and whiskers extend from each quartile to the extreme data points. Well, let's just jump right in and do one. All right, so we're going to, first of all, need to calculate the median of this. So we check to see if our points are in order from smallest to largest. And they are. So I'm going to move up here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. So I'm going to move up here 5. 1, 2, 3, 4, 5. I'm going to move down 5. 1, 2, 3, 4, 5. That tells me my median is somewhere between 17.9 and 17.9. So my median is equal to 17.9. I can calculate then the upper quartile would be the middle point here. So if I go up 2 and down 2, my upper quartile limit then is 19.9. Upper quartile is equal to 19.9. My lower quartile, I'll go down 2 and up 2. My lower quartile then is equal to 16.2. As I find the difference, to find the interquartile range, the difference between those two, is 3.7. So the interquartile range is 3.7. I take that value and multiply it by 1.5 to find the extremes, the values for the limits for the extremes. 3.7 times 1.5 is 5.55. So the upper limit would be 19.9 plus 5.55, and it tells me my upper limit is 10.65. I'm sorry, is 25.45. That's my upper limit. My lower limit is 16.2. And I'm going to subtract the 5.55. As I subtract 5.55, I get 10.65. If I look at my chart here to see if there's any outliers, as I start at the bottom, the lowest term is within my range, and as I move on up, 34.8 is an outlier, so it lies outside my range. I'm going to start with a number line here and make sure it includes all the values that I have. The lowest value here is going to be greater than 13. The highest value is going to be less than 35. So I'm going to plot the extremes here. It's 13.5, which would be about right here. The lowest, or rather the highest value is 34.8, which would be about right here. Then I'm going to plot the middle value, or 17.9. 17.9 would be about right here. All right, 17.9. The lower quartile would drop down to 16.2. 16.2. And the upper quartile limit would be 19.9. So I draw a box that includes those values. And whiskers are that go out and go to the highest value that's still not an outlier. The highest value that's still not an outlier would be 20.2. 20.2, and the lowest value would be 13.5. So that's the box and whisker plot for this data. All right. Looking at these, they've already drawn the box and whisker plots, but let's figure out which one matches our data. First thing I want to do is look at and see are my data points in order from smallest to largest, and they are. And there's 1, 2, 3, 4, 5, 6, 7, 8 data points. So I'm going to drop down 4, 1, 2, 3, 4, and I'm going to go up 4, 1, 2, 3, 4. So my median value is the average of 2.0 and 1.5, so the median is going to be 2.0 plus 1.5 divided by 2. When I divide that out, it's 3.5 divided by 2. 3.5 divided by 2 is 1.75. I calculate my lower quartile. Well, I come down to and up to, so it's between 1.3 and 1.2. So the average of 1.3 and 1.2 is 1.25. The upper quartile, again, I go up to and down to, and it's the difference, or it's the average of 3.7 and 2.9. 3.7 plus 2.9 divided by 2 is 3.3. So let's look at some of our graphs and see if that's the upper quartile limit. This is the lower quartile limit, and the median is 1.75. Let's just check that. Well, median value 1.75 checks out for A, so A is still a possibility. B, it checks out at 1.75. C does not. They have their median much too high, so it's not C. And if I look at letter D, I can see my median is much too low. So it's either A or it's B. Let's check the upper quartile and lower quartiles. And just looking at the boxes, I can see that they stop and start the same. So those upper and lower quartile values still seem to work. Here we've got the line here that indicates the whisker goes all the way up to the maximum value, which in this case is 8.0. So I got to check to see if 8 is an outlier or not. An outlier would be anything that's greater than 1.5 times the range, the interquartile range. So the interquartile range is from 3.3 to, 1.25 to 3.3. So if I find the difference there is 2.05, and I multiply that by multiply that by 1.5. That gives me a 3.075. And I'm going to add that to my upper range, my upper quartile, and that would become 6.375. And you can see that 8 does lie outside of that. So I need so this one is incorrect. It has to be answer A, because this one shows the whisker stopping at the right point rather than going all the way to the extreme value. All right, so the answer is A. What do the links of the parts of the box and whisker plot below tell you about the data? Well, as I look at it, I want to look at how much it changes, or the distances here. It looks like this value in the second quartile is much more spread out than the value in the third quartile. So the second value, the second quartile data is more spread out than the third quartile data. And if I look at it, this data in the fourth quartile is the most spread out of any of the data on the chart. All right. Which statement does not describe the data in the box and whisker plot below? All right, well, let's just look by statement here. Let's look at number A first. The data in the second quartile are less spread out. Well, that would mean that this distance right here is less than the distance in the third quartile, and that's a true statement. So A is true. The data in the fourth quartile are the most spread out. That would mean that this distance, the fourth quartile, has to be bigger than the third quartile, and it is not. So B is going to be false. Let's check the other two. The greatest range of data is in the third quartile. That's true because it has the greatest distance here. So C is true. D, the median is less than 8. Here's the median, and it is definitely less than 8. So D is true. So the only one that's false is letter F. Refer to the double box and whisker plot below, which month had the greatest range in high temperatures? Justify your answer. Well, if I look at this, this is 25. So this is 26, 27, 28, 29, and 30. So the greatest range would be from 20, well, this range would be from 27 up to 30. So its range would be 27 minus 30 is 3. Let's check this one down here. This goes from 21 through 26. So 26 minus 21 is equal to 5. So April has the greatest range because it shows the greatest spread, the biggest spread from the extremes. Refer to the double box and whisker plot below. Which month had the greater range in high temperatures? High temperatures. Well, if I look at July here, July went from probably, I'll call that 72 to about, say, 92. So 92 minus 72 is equal to a 20-degree spread. May went from about 50 up to a high of, say, 82. So 82 minus 50 gave me a spread of 32. So May has the greater spread, the greater range in high temperatures. So May had greater fluctuations than July.